Welcome to Study Loop.
Now we'll work on problem 88 from chapter 17. Here, for several compounds, we're given molar solubility, and we're asked to calculate the KSP. So for all the equations, all the chemicals, we can draw the equation for the dissolution of the ionic compound. So first we have barium chromate, and that can dissolve to form barium 2+, and chromate BaCrO4 2-. Now if we draw our ice table, we have no initial concentration, a change of S. And so now we're given molar solubility, so we have KSP is equal to S squared from this here, S times S. And this is equal to, or we can plug in for S since that's what we're given in the problem, 1.08 times 10 to the minus 5. Let's make sure this looks like a 5. Squared. And so if we take the square root of both sides, we can get S is equal to 1.17 times 10 to the minus 10. So we can move on to part B, where we're given silver sulfite, Ag2SO3 solid, dissolving to form two silver cations, and the sulfite anion. So if we draw our ice table, we have no initial concentration of the ions. We're going to add 2S because of the coefficient of silver, S of sulfite, S2S, equilibrium for silver, and S for sulfite. So when we have this ratio, these terms here for the equilibrium concentration, the KSP will be equal to 4S cubed. And we can go ahead and plug in our molar solubility here, which is 1.55 times 10 to the minus 5. And when we do this calculation, we get a value of 1.49 times 10 to the minus 14. Now for the third part, part C, we're given palladium thiocyanate, PdSCN2, which is a solid and can dissolve to give palladium 2+, aqueous, and then 2SCN minus aqueous. We do our ice table. And we can draw our term for KSP, which because we have S and 2S, when we multiply them together and square 2S, we get 4S cubed, which comes from here, to be clear. And so when we plug in the value that we're given for S, which is 2.22 times 10 to the minus 8, cubed, we get a value of 4.38 times 10 to the minus 23.